All right, Harmony Science Academy Honors Geometry students, welcome back to semester 2. Let's go ahead and get off to a good start here, okay? As far as this class, the learning topic is similarity, okay, amongst polygons. So let's go ahead and give you guys some vocabulary. Find time in the class to pause, go visit the online textbook or just do a Google search so you can get the definition and example for these words, okay? It'll definitely help you guys out. All right, so with the problems we're going to be looking at, let's kind of scan it, okay? They're going to look like this, okay? Goes all the way to 24, okay? And there's a lot going on here, but here's the main thing, is here we have some algebra to start off, and the way you solve some of these geometry problems that are about to come is by setting up these proportions, okay? And you set up these proportions for figures, polygons that are similar, okay? So for example, when we talk about similar, it's if, for example, let's say I have a 30, 60, 90 triangle, okay? If I blow that up, right, it's the same triangle, just larger, that's similar. But, right, so these two would be similar. We'll put a check mark, okay? But if I compare him, let's say, to this triangle right here, okay, that's not similar, okay? So even though with these two the sides aren't the same, they do have the same angle measures. This one does not, okay? Now, when you have these sides that are the same, let's call this A, B, and C. We'll call this D, E, and F. The way you set up these proportions is, okay, A over B from this triangle is going to end up equaling D over E, okay? So notice that I took A and B, and it matches up with D and E. I did not put D over F. Okay, that would give you a different ratio. They wouldn't match. But when you have similar figures, the corresponding sides that produce a ratio, okay, or a proportion, will equal the corresponding sides for the similar triangle, okay? So that's pretty much the lesson in a nutshell, okay? So the first thing we're going to do before we get to some geometry, you guys will get to solve some proportions, okay? A couple of practices. So let's do number 3. Now you guys will set them all up the exact same way. Some of these might require a calculator, so feel free to set it up and then use a calculator, okay? So in this case, you should have learned to cross multiply. So 6 times 4 is 24. And 2 times x is 2x. Divide by 2 and we get x equals 12, okay? Now in your case, if you need the calculator, feel free to do so, but at least cross multiply and set it up just like that, okay? Alright, so up to 10, you guys, actually up to 12. So half of the assignment will be just working on some of those algebra skills, okay? Now, we get into the lesson, okay? State if the polygons are similar, okay? So if they're similar, that means that if I create a ratio, right, of 16 over 12.4, it should equal 12 over 9.3. Okay. Now notice that's going to be hard to do by hand, so you definitely want to use the calculator for that. Okay. So the other ratio that we're going to check is 16 over 24. Okay. And that ratio should match up 12 over 18. Okay. So I'm basically doing one for you guys. I'm setting it up. So here's all I'm going to say is yes, this does check out. So you guys want to go ahead and put in the calculator. Okay. What should it look like? Here's what you guys will do. Since this one doesn't need a calculator, I can reduce it, right? This is basically 2/3, which equals 2/3. Okay. That's what you guys are going to do. You'll punch that in the calculator. Okay. You'll put it here, equals that. But I'm telling you right now, in this case, yes, this one is similar. Okay. But for the reason I know is because I've already checked this proportions equal each other, these equal each other, and the other one you want to check is 12.4 over 24, and that should equal 9.3 over 18. Okay, so again, only to save time, since I would need the calculator, I've already done the scratch work, but it does check out for all three. I should do it like that. Excuse me. Okay. So you guys go ahead and run the calculator here, and to prove that this equals that, run the calculator with these, and also check that this equals that. Okay, that means that you can do the rest of these by running this test. If you get to one where it's not, you're done. All you have to say is not, like this, not similar. Okay, but if you check it and that's correct, you go to the next one, then you go to the next one, and if the three check out, then it's similar. Okay, all right. Let's go ahead and move on. So you'll be able to tell me if that this is similar. Show me the work. You'll do the work here and tell me if it's similar. Okay, let's move on to this one. Same thing. You'll do the work here. Tell me if it's similar. Okay, and this one, since it's pretty obvious, right? Let's do this one real quick. Just kind of start it. If I put 10 over 12, right? Does it equal 5 over 5? Okay. Some of you guys already know, but you can put in the calculator. This becomes 5, 6. And 5 over 5 is 1. That doesn't equal. So you can put an X and right away say not similar. Okay? All right. Let's go ahead and move on. Okay? Now these, they ask you, is it similar, yes or no? Here, they're telling you, yes, the polygons are similar. Find the missing side. Okay? So let me go ahead and do 18. I'm sure some of you guys already know what to do. But the fact that they're similar means I can set up the proportions that I want. Okay, do I have to do all of them? No. I do them over here, right? So I can check, right? Where were we? I have to do all three to check to see if it's similar. Over here, they're telling me, hey, it's already similar. So I know that whatever corresponding proportions I take are going to check out. Okay. So anyways, here, find the missing side. Here's the missing side. So here's, look at how I'm going to set this up. This is how you'll set the rest of them up, okay? So the corresponding side to 25 is 15. So I got 25 over this 15, and it should equal this 15 over this question mark, okay? I'm going to stop here. I'm not going to do the work. I'll have you guys do the work, but I will give you the answer, okay? So this question mark is 9, the unknown is 9. So you guys go ahead and do the math here, right? The way we started the lesson. And if you get a 9, that means you did it right, okay? So I'm going to stop there on that one. And the last problems will look like this, okay? These are the more advanced problems, but you're going to approach them the same way. So it says solve for x. The polygons in each pair are similar. Okay, so where was I? Let's go ahead and pick, let's see here. Let me see which one of these is good. Okay, let's go ahead and take this 21 here, okay? Now, again, this is a little more advanced, but you're going to use a lot of what you've already picked up on. which is this, pay attention, okay? They're saying the scale factor from A to B equals 8 to 9, okay? So this is the ratio in terms of the size difference, the relationship, okay? So look how simple this is, okay? So you guys can just complete the assignment. We're going to go ahead and, this is figure A or polygon B, right? So I've got 6x minus 8 over, right, A to B. So this is the value representing A, so 8, okay, and B, okay. Now notice that they also shifted the figure. Okay, it looks a little awkward, but if you turn this one or you turn that one this way, you'll find that this and this correspond, okay. So anyways, so the 72 corresponds to 6x minus 8 over this 9, okay. So now I'm gonna, well, I can't perform the math here, but you guys are awesome at your algebra. I'll give you the answer so you can check it, and the answer would be x equals 12. Okay, so go ahead and cross multiply, solve for x, and if you get 12, that means you're doing it correctly, okay? All right, appreciate your time. We'll catch you in class, guys. If you have any questions after looking at this video, let me know. We'll work them out together, okay?